probability that this will land on a green?
2 out of 7.
Yeah. This one's okay. Any idea how you find a missing probability?
I'm not sure.
What do probabilities always add up to?
100.
100%, which is the same as 1.0 or just 1.
Okay.
And
So would you add those 3 up and then take it away from 1?
yeah, you'd be fine there. Okay. Just looking for one that we didn't. That's fine. Okay, so this part B, she's going to spin the spinner 200 times. How many times would you expect it to land on 3? Any idea how you'd do that?
Well, if you spin it 1 time, then the probability is 1 out of 4. So
that's just a diagram, or that's just like a picture. It's more about the table. Yeah, it's kind of a misleading diagram that it makes it look like it's 1 out of 4 when really it's each one of those has a different probability.
I don't know, would you times it by 200?
You would?
So 0.1 times 100.
Yeah. Any idea what that is?
I don't know, is it
0.1 is the same as 1 over 10.
So 20.
Yeah, 20. Basically 200 divided by 10. Yeah, if you had a coin and you flipped it 100 times, how many times would you expect it to land on heads?
50.
Yeah, and so basically it's always, so you flip a coin 100 times, the probability of it landing on heads is 0.5, and so you do 100 times 0.5. And the rule for that is, so that's called a relative frequency. Basically, probability times by number of trials. So that's like number of times you flip the coin, number of times you roll the dice, equals the relative frequency. Okay. So this one, how would you get an estimate for the number of times this lands on 2?
So would you do 0.3 times 200?
Yeah. Any idea how you do that?
So it would be 3 out of 10.
Mm-hmm.
And then do 3 times 20.
Okay.
90.
3 times 20?
Oh, 60.
That's it, 60. Okay. Any questions there?
No.
Okay, you got it. So these ones are similar. Any idea how you would find x for this one? There's now 2 unknowns.
Would you just add the 46 and 28
Right.
and take it away from 1, and then whatever the answer is, divide by 2?
That's it. So 1 is your answer, gives you that, and then divide your answer by 2, and you get 13 over 100, or as a decimal, 0.13. So that's 0.13 for x, and that's 0.13. And then in part B, they said it spun 5 times. How many times do you expect it to land? 4. And so then you're using your 0.13 times the 500. Oh, we started probability tree diagrams. Okay, so this is where we stopped. Okay, so this is when they don't give you a diagram. Okay, I'll let you read that. Tell me what you think.
Yeah, I wouldn't know how to approach that further.
So what you could do is list the successful outcomes, they call them. So basically, what are the successful outcomes if you took 2 pens?
So like 2.
So let's say what 2 colors could you get for it to be success?
Wait, what did you say? Like broke up.
Sorry. Like what? So give me an example of like 2. So you take 2 pens. Give me an example of what 2 colors you could get. So it's successful.
Red,
Mm-hmm. So
blue, green.
so let's say you take a pen out. It's red. What would the next pen have to be?
Red.
Yeah. Okay. Another successful outcome would be
Blue. Blue.
yeah.
And green and green.
That's it. So those are your 3 big chances. Okay. What's the probability of taking a red out first?
1 out of 5.
How many red pens are there?
Oh, 5.
Yeah. And how many pens are there in the box in total?
Oh, okay. So 5 out of 10.
Yeah. Don't put the pen back in. So what's the probability of taking another red pen?
Um, 4 out of 10.
It was 10, and you took a red out.
9.
Yeah. Any idea how you find the probability of getting both a red and a red from the box?
Would be like, what if you had 2 times, like picking one out?
So basically, like, the probability of getting a red first is 5 out of 10. The probability of getting a red second is 4 out of 9. What is the probability of getting, like, one probability of a red then a red? How would you combine them to be one probability of red then red?
Would you add the 2 we've got?
No. Let's see. Just trying to see if there's some obvious way, because we kind of skipped some stuff. Let me do it like this. Yeah. So in the beginning, so the box has like 10 pens, and let's say the 5 pens are in here. So let's say the 5 pens are on the left, the 5 reds are on the left one. So that's 5 out of 10. And then once you take one, the 4 of 9 are here. So any idea how you find this here? Any idea how you'd find the area of that? How do you find the area of a rectangle?
Times width by length.
Yeah, and so for this one, the base is 5 over 10. The height is 4 over 9, and you're timesing them. And so what would you get there?
90. And 20.
That's it. So if I just go back for a second. Okay, so bringing those two together, you get 20 over 90. Okay, how about the blues?
3 out of 10. And 2 out of 9.
Okay. What's next?
And then times
Yeah.
So you get 6 over 90.
Sweetheart?
That's it.
Oh, you have a
And last one?
2 out of 10. And 1 over 9.
Yeah.
And then times them to get 2 over 90.
That's it. So if you have both and in probability, so like they are both red and red, both blue and blue, both green and green, you multiply, and if you have either or, you add. So any idea how we combine these three to make one probability? So basically you've got 20 chances out of a total of 90 with getting 2 reds. You've got 6 chances of getting 2 blues and 2 chances of getting 2 greens. How would you combine them to make just one probability of getting 2 pens with the same colour?
Add them.
Correct. You can get either 2 reds or 2 blues or 2 greens. So it's like either. And so what is that as a final answer?
28.
Out of?
270.
What is 2 over 7 plus 3 over 7?
Oh, 5 over 7.
Yeah,
So it'd be over 90.
that's it. Yeah, so it's basically 20 chances, 6 chances, 2 chances. The total chances is 90, and so it's 28 chances out of 90. Any questions about anything there?
No.
So this is probably the hardest topic that there is. I think second hardest. I think vectors is harder, but this is usually the very last topic. Let's see, they're not the same type. Let's try this one. Let's find the probability. So that's they're not the same type. Let's find the probability that they are the same type. How would you do that?
So would it be like 12 out of 20?
Yeah, and okay, yeah, go on.
And then would I do that thing where I do the same?
So I was going to say maybe list the successful outcomes first and make it a bit easier.
So then 5 out of 20.
Are you doing different types?
Oh, the same.
Yeah, I'm changing it to be the same. So let's say your first biscuit you take is plain. What would your second biscuit have to be successful?
Plain.
Yeah. What are the other successful outcomes?
2 chocolate biscuits.
Okay. And last one?
And then 2 ginger biscuits.
Yeah, and it's kind of helpful to have those at the top because you're going to lose your way in the middle of a long question. Okay, so what's next?
And then do you do the thing that I was doing before?
Yeah, I think so.
So then 5 over 20 and 3 over 20.
So we said it would be a plane, then a plane. So probability of taking a plane was 12 out of 20. What would be the next thing you would take?
Um, a cho-
So we said for the first one to be successful, so they both are the same. It would be plain then plain. So probability of a plane 12 out of 20. And then what's the probability of taking a plane again?
11 out of 19.
That's it.
And then for the next one, would it be 5 out of 20 and then 4 out of 19?
Mm-hmm.
And then 3 out of 20 and 2 out of 19.
Got it. Okay, what's next?
And then don't you times them?
Mm-hmm.
So how do I times the first one? Is it the TP method?
To multiply fractions, you just multiply top by top, bottom by bottom.
Oh,
Any-
okay.
Any idea what that would be for this one?
So 20 times 19.
Do you know what that is?
No.
That's 380. Any idea about 12 times 11?
No, I'm not sure.
So to multiply by 11, so the other number, just split the numbers apart. So 1 there, 2 there. And what is 1 plus 2? And so 3 goes in the middle. That'll always work for 11 if you're ever stuck. First number to the left, second number to the right, add the 2, put the answer in the middle. Okay, so what is the second one?
Oh wait, so whenever you times a number by 11.
Yeah.
So if it was like 13.
Yeah.
It'd be 1, 4, 3.
Yeah, let's take a look. 11.
Oh, okay.
Yep. Yeah.
Okay. So then this one is 20.
Mm-hmm.
And the next one is 6 over 380.
Okay. How do we get a final answer?
And then do you add them?
Yeah.
To get 158 over 380.
That's it. 158 out of 380. Yeah, so it's basically the probability of getting plain and plain plus the probability of getting chocolate and chocolate plus probability of getting ginger. And yeah, those are your 3 chances for success. You add those up and that's what you get. Any questions about that?
No.
That was the probability that you get 2 the same. Any idea how you get the probability of not 2 the same? So the probability that they were not the same type.
Would you take away or?
Yeah.
So at the end when you add them, would you take them away?
No. If you rolled a dice, what's the probability it lands on a 4?
I'm not sure.
If you flip a coin, what's the probability it lands on tails?
Um, 1 out of 2.
Yeah, so you have one chance of being successful. There's 2 possibilities in total. So what's, if you roll a dice, what's the probability that it lands on a 4?
1 out of 6.
Yeah. What is the probability it does not land on a 4? Oops.
Uh, 5 out of 6.
That's it. How did you get 5 out of 6? And what do you notice about 1 out of 6 and 5 out of 6?
If you add them, there'd be 6 over 6.
Yeah, and what is 6 divided by 6?
1.
Yeah, so they add up to 1. So for this question here, there's 158 chances out of 380 that they are the same. How would you figure out the probability that they're not the same?
Would you do... Would you do a 380 take away 158, and then whatever the answer is, put it over 380?
Correct. That's it. So it's 380 take away 158, 222. And so it is 222 over 380, like you said. And that's what I've got down here. 222 over 380. That's true for all probability. So if you think about the coin, the probability that it lands on heads is 1 minus the probability it lands on tails. If you do 1 minus 1 over 6, you get 5/6. And if you do 1 minus 158 over 380, you get 100. Did I do something wrong? Oh, they simplified the fraction. 222 over 380. The calculator automatically simplified it at half to the top and bottom. Yeah, and so you can always, if you need to find the probability of something happening, you can always just do 1 minus the probability of it not happening. Or like you did, just do like 380 minus the 158 and put your answer over the denominator.
Okay, so if you're looking for if they're not the same, you do it as if you're working it as they are the same, and then take it away at the end.
Yes, and so what we could have done was, what are the possibilities where you get 2 biscuits where they're not the same? So they take 2 biscuits.
Would you do like 20 take away 12?
So just no numbers yet. Just what are the successful outcomes? So we said like plain, chocolate, ginger, ginger. What are the successful outcomes if they are not the same? If you take 2 biscuits, they're not the same. What possibilities are there?
Plain and chocolate.
Yeah.
Plain and ginger.
Yeah.
Chocolate and ginger.
Yeah. If you worked those out, you would get 111 out of 380. So if you take a plain then a chocolate, they're not the same. What if you took a chocolate and a plain? They're not the same either, but it's a different thing. And so you could either do all 6 of these, which is more work, or you could just take your answer and double it because of this, it works either way. And if you do that, you get the same answer that you got, 222 over 380. With finding the not the same thing is you have to remember to double it at the end, or you have to do 6 things. Whereas if they're the same, it's just an easier thing. Well, plain, chocolate, chocolate, ginger, ginger. Like you have to think a bit like, what is the third one? So it's just a bit more work. It's just easier to do the 1 minus thing, I think.
Okay. I get really confused after we've done like not the number bit but just the like writing the first bit down. And then what do I do after that again? So after I've wrote down like chocolate, ginger, ginger.
You just find those probabilities. So what is the probability of taking a plain then a plain, or a chocolate then a chocolate, or a ginger then a ginger?
Oh, okay. And then like as a recap, after that, you just times the 2, and then the answers of all of them, you add them if you're finding. So you add them if you're finding if they are the same, the probability that they are the same.
You do the same method each time if they are the same or if they're not the same. It's just that if they are the same, you're finished. If they're not the same, you do 1 minus at the end, like you did, the 380 minus 158.
Okay.
Yeah, so it's tricky stuff. Okay, let's try this one.
So first you write down all the possibilities of numbers, so like 1, 1, 2, 2, and 3, 3.
So part A just wanted the probability of 1, 1. Number 1 on both of them.
Oh, okay.
How do you get that?
So 1, 7. Is it 1 out of 7?
So it's quite a confusing question. How many number 1 tiles are there out of the total?
2.
Yeah. And so the fraction would be probability of taking a 1.
2 out of 7.
Yeah. Okay. What about?
Oh, okay. Yeah, that's quite. Would it be 5 out of 7?
So after you take 1, 1, what's the probability of getting the second one?
One
Mhm.
out of 6.
Yeah.
and then times them.
Yeah.
So it would be over 42.
Yeah. Okay. Part B. I'll let you read that.
So would this be 5 oh, do I have to write down the possibilities?
Yeah. I think it's a good start.
So 2 so 2 and 3,
Mm-hmm.
and then 2 out of 5.
So what are the possibilities? So you could take a 2, then a 3. So the second card is bigger than the first. Are there any other possibilities where you take 2 cards and the second one's bigger than the first?
2 2s and 2 3s.
That would be the same. The second card needs to be bigger than the first.
I thought it meant like. Wait, so would 2 and 2 not be 1?
That would be if the second card was the same as the first. They said the second tile has to be greater than the first.
3 and 3.
That's the same. So this one was correct. So first he takes a 2, then he takes a 3. So the second one is bigger than the first. So
Oh, okay. Okay, yeah. So 1 and 2.
yeah. Is there any other possibility?
1 and 3.
That's it. Okay, what's next? So we're trying to find the probability of getting either a 2 then 3, or 1 then 2, or 1 then 3. Say it again, sorry.
Would it be 2 over 7?
How many 2s are
Oh, would it be 2 fractions for the first one?
there? Yeah. So what would the fractions be?
So the first one would be 3 over 7,
Yeah.
and then the second one would be 2 over 7.
They already took one. So after you take a 2 tile.
6.
Yeah.
And then 2 out of 7.
Yeah. how many 2's are there? Can you hear me?
I can now.
Okay. So how many 2's are there after you take a 1?
3.
Yeah. Okay. How about probability of 1 then 3?
So 2 out of 7,
Yeah.
and then 2 out.
That's it. Okay. What's next?
And then do times them all.
Yeah.
So you get 6 over 42,
Okay.
6 over 42, and 4 over 42.
And so, what's the final answer?
16 over 42.
That's it. 16 over 42. What is the probability of you take 2 cards and the second is bigger than the first? Well, forget probability. The possibilities are 2 then 3, 1 then 2, or 1 then 3. Probability of 2 then 3 is 6 chances. Second one 6 chances. Third one 4 chances. And in total 16 chances out of a total of 42, or 16 out of 42. Okay, any questions there?
No, I don't have any questions, but I think I need to work on that because I feel like there's quite a lot of steps that I would forget.
I mean, everyone needs to work on this. It's very difficult. Okay, how would we do this one?
So first of all, would you write down all the possibilities?
Mm-hmm.
So, egg and cheese,
Mm-hmm.
egg and ham,
Mm-hmm.
cheese and ham.
Okay.
And then would you do fractions? So for the first one, 4 out of 11, and then 5 out of 10.
Mm-hmm.
4 out of 11, and then 2 out of 10, and then 5 out of 11, and then 2 out of 10.
Uh-huh.
And then times them. So for the first one, it'd be 20 over 110.
Uh-huh.
For the second one, it would be 8 over 110. And for the third one, it'd be 10 over 110. And then add them to get 38 over 110.
110. And so that's, you get an egg and cheese. If you got a cheese then egg, would that count as 2 different ones?
No.
Seem different to me.
Wait, compared to what? The ones we've already chosen?
Yeah, so for let's say the first one, like you take egg then cheese. You could also take cheese then egg. So if you got, on your first, if you take first egg then ham, or you first take ham then egg, or you first take cheese and ham, then you first take ham then cheese. So they're different things, but they're still successful. So any idea what that tells you about your final answer?
So is it wrong because there's more possibilities?
What way did we do it with this one?
We took it. Oh, we swapped them all around.
Right. And so there was 111 chances for these three. And there was 111 chances for these three.
We added them.
Yeah. And so what could we do for this one?
Do 38 times 2.
Yeah.
So then you'd get 46.
Seems kind of small.
Oh wait, 76.
That's it. And so what's our final answer?
And then over 110.
That's it. 76 over 110. So that's 76 over 110. So basically, if this was what's the probability that she takes two of the same type of sandwich, yeah, you would have gotten full marks because that's what you did. Well, you did all of that. The trick with the different ones is that you double it at the end because it can be doubled. This one here, we didn't double it at the end because a 2 then a 3 is not the same as a 3 then a 2 on this one because the second one had to be bigger. So, and there was another way of doing this one. If you had gotten the probability of getting the same, so the probability of the same was, let's say it was 34 over 110, how would you get the probability of not the same? Using that answer.
Do 110 minus 34.
Yeah. So you've basically got two choices. So this one you were good for because there's just one thing, and then this one you're good for when they're the same color. If they're not the same, you can either find the probability of half of them and then double it, or you can find the probability that they are the same and then do 1 minus, and either way you will get the correct answer. Any questions with that one?
No.
Okay, and so that was the last exam question for these probability trees, and I'll look them up, but they're considered the hardest thing in foundation. I'll just do a recap. Okay, you'll recap for me. How do you get a missing probability?
You add them all up and minus them from 1.
How would you get a missing probability if there were 2 missing and you knew the 2 of them were the same?
You'd add them up take it away from 1, and then whatever the answer is, divide by 2.
That's it. And one of those 2 questions is very common. Either there's 1 missing or there's 2 missing. And you can see these are all exam questions. It's just the same thing over and over again. I just want to see if there's one. For this one, if I, what is this? Okay, so if I took like a ball out and put it back 300 times, how many times would you expect me to get a red? How would you do that?
Times 0.3 by 300.
That's it. So that's 0. So it's, yeah, probability times the number of trials. That gives you the expected number of outcomes. We call it relative frequency or expectation. So you would expect to get 90 reds if you took, you did that thing 300 times. Be like if you flipped a coin 50 times, you'd expect to get heads 25 times. It's not exact, but that's why we say expect. Probability trees. Yep. Okay, so how do we do these questions in general if they're the same color? If it's the same thing?
You work out what the possible outcomes are,
Mm-hmm.
and then you do the 2 fractions for each one.
Right.
And then you times them together.
Yeah.
And then you add them together.
Mm-hmm. And that's it?
Yeah, I always get confused on the last bit. So if we're working out the probability that they're the same, do we keep it the same? And if we're working out the probability of if they're different, do we take away whatever the numerator is from the denominator and then put it over the original denominator?
Correct. That's it. The thing though is if you getting the ones that they're the same, then you just do it the way you did it. If you're getting the probability that they're different, what you do is you first get the probability that they're the same, and then you do that denominator minus numerator thing.
Okay.
Yeah, and that's how that one works.
Okay.
Yeah, how did you find that, Ellie?
I found it quite hard.
Yeah, it's very hard. Any idea what you